Here's one. F of x equals 3 over x minus 1. Find the limit. Where's my eraser? Find the limit of f of x as x approaches the 1. And again, if you try direct substitution, you have what? 3 over 0. So you really can't do direct substitution. Can we simplify? Can we factor it? Can we do something about it? No. So what's the only thing left there?
Make a chart.
Chart, table. Last resort is the table. If everything fails, the table is the way to go. We're approaching the 1. Let's look at it from the left side. 0.9. You're not a 1 yet. 0.99. 0.999. That's the left side. Then we'll do the right side. We'll try 1.1. 1.01, 1.001. Is that negative 3? I think negative 3. I think this is negative 33. Negative 333. What do you think that number is going toward? Which one? Negative infinity. Yep. So now they're going to say to you the limit, and you're going to see that for the first time. I've been writing it, but our book wasn't writing it down yet. They weren't giving you problems like these. From the left side of f of x, now that's a negative infinity. So if they ask you from the left side, you have to write minus infinity, and that does not exist. From the right side, this will be what? Is that a 30, the first one? I think that was a 30 here. I think that's, maybe I was wrong. Let's see what that number here. That's 300, I think, here, huh? And 3,000, yeah. This will be 30. This will be 300. This will be 3,000. And where is this going to? Positive infinity. So now they're going to be specific. Positive infinity or negative infinity. One from the right side, the answer is infinity. If the question again, what's the limit of f of x as x approaches 1? What is your answer?
Infinity.
How about does not exist? Why does not exist?
Because
They don't match.
yes.
On the other hand, if I change that question just a little bit, I can give you an infinite limit, and you will have to write in this section approaches infinity. No more does not exist.
Only if they ask from a specific side.
Nope, even if it's not. Watch. The limit of 1 over x squared as x approaches 0. Direct substitution. Should just put a stamp that says direct substitution on it. Just stamp it there. 1 over 0. Says, nope, can't do it yet. So now we do the chart because you can't simplify that. Let's try from the left side, negative 0.1. I think that's 100. Let's try negative 0.01. That's a 10,000. Negative 0.001. That's a 1 million. Where's that number going toward? Infinity, positive infinity. So the limit of 1 over x squared as x approaches the 0 from the left side is approaching infinity. What about from the right side? Let's try the 0.1. That's also 100. Let's try 0.01. 10,000. 0.001. 1 million. That's going to infinity. The limit of 1 over x squared as x approaches the 0 from the right side is also infinity. Are they equal to each other? There is a limit, and now you write the limit of 1 over x squared as x approaches 0. It no longer does not exist. We go infinity. We have an infinite limit.
So for the last one, the first one we just did, they would have to ask for a specific size. Otherwise, it does not exist. For the 3 over x
Correct.
one.
Correct.
But for that one,
For this one, they can ask for either one of these, or they can ask for this. Yep.
it's infinity all the way around. That's right.
And again, you look at pictures like these. If we said to you, I don't know if you can see it. Can you see that on the screen? What's the limit as x approaches minus 1?
Can you zoom in there?
I can't when it's on video. Yep. When it approaches minus 1, what's the limit? Does not exist, because from the left side is what? Negative infinity. From the right side is what? Positive infinity. So we can't. There's no limit. There's no answer as x approaches minus 1. This one, what's the limit as x approaches the minus 1 from the left side? Infinity. From the right side, negative infinity. There's no limit as x approaches the minus 1. The same thing right here. From the left side is negative infinity. From the right side is positive infinity. There is no limit there. All these lines going up and down. These lines, rather, are called vertical asymptotes. You probably heard that. That's where the function, the value on the bottom is equal to 0. And that's where your graph is either going to go to plus or minus infinity. It's going to blow up when you graph in a picture there. So you'll know what the graph looks like. I can actually cheat a lot of times, watch this, by knowing the vertical asymptotes, because that's actually the last piece beside infinite limits, is the vertical asymptotes. Finding the vertical asymptotes. The first one, if I have this, we call the vertical asymptotes VA. What are the vertical asymptotes? Well, this one, there's only one vertical asymptote. Where is it? You look at the denominator, it says what value makes the bottom 0? -1. So your vertical asymptotes at x equals to minus 1. So if you go to graph that one, this is the minus 1. You put a dotted line. This is x equals minus 1. That's your vertical asymptote. What that tells you, actually, as you approach this line, your function is either going to go to plus infinity or to minus infinity, as you approach it from both ends. So as I approach this red line here, my graph is either going to go to plus infinity or to minus infinity. As I approach it from this point, it's going to go to plus infinity or to minus infinity. I'm not sure where. So you can, if you want to graph it, you can start by picking points and see, okay, minus 50, minus 40, minus 20, and that'll give you an idea. So if I want to graph this quickly without spending 6 hours on it, I go, let's pick values for x. Let's try minus 10. Then I'll get closer to the minus 1. I'm doing this side here. How about the minus 2? I'll try these two numbers. When x is minus 10, what do we have? That's a minus 9 times 2 minus 18, negative 118. Almost what? 0? Somewhere here. Almost a 0. What about the minus 2? What's minus 2 plus 1? Minus 1 times 2? 1 over minus 2, negative 1/2. Is that going up or down? So my graph is going to look like this. I don't have to continue even, just these 2 points. Because I know as I approach that line, I'm either going to go to plus or minus infinity. Well, the fact I'm coming down, that tells me the function will continue to go down. Color points on the right side, and I'm done. Let's try it to the right of the minus 1. Let's take a 0. 0 gives me what? 1/2. Somewhere here. Let's try the 5. 5 and 1, 6. Is that 112? That's also close to 0, right? So it's going, if you travel this way, it's going up higher. See, it's rising. Whereas you approach this, you're either going to go plus infinity or minus infinity. Well, since it's rising, where is it going to go? That's my graph.
And it's never going to touch negative 1. Right?
Nope. That's asymptote. That's why they call them asymptote. You approach them. So what's the limit as x approaches the minus 1 from the left side?
Negative.
From the right side? There's no limit. But notice I graphed that with 4 points, once near a vertical asymptote. I can take a complicated one. One looks like I have no idea what the graph looks like. And I'm not being funny here. I have no clue. We're going to graph that in about maybe 5-6 points. 2, 4, maybe 7 points top. My vertical asymptotes, where are they? Yep. At x equals positive and negative 1. These are the values that will make the bottom 0. Because if you factor this, isn't that x plus 1 times x minus 1? If you factor the bottom. So you have 2 values that will make the bottom 0. One is the plus 1, one is the minus 1. So there is the plus 1, and there's the minus 1. Here's my vertical asymptotes. Again, as you approach them, your function is going to blow up. It's going to go either all the way to infinity or all the way down to negative infinity. And here we go, x. I'm going to get my calculator ready here. Where is it? Turn it on will help. Clear. Clear. Boy, it's been a while since I looked at the calculator, so. Oh, here we go. I'm going to graph that. Oh, yep, okay. Okay. Table, here we go. Let's pick some values. Let's pick a number to the left of -1. Should we try like a -5? If you plug in -5 in it, I think I froze my calculator, just died. Wait, is it?
Yep.
My calculator just froze. Okay, clear. I can't type anything in it. Oh, wait. Oh, I know. Table set. Okay. Let's see. There we go. Let's see if my calculator is working. Yep. 1.08 you got? If I try a -2, close to the -1. 1.7 roughly? 1.6667. So one of them is 1.0. So this one here is going to be roughly 1.1 right here. The other one, when you approach that 1.7, is rising. It looks like this. It's not really approaching the 0. What do you think that number is approaching to? That's a 1. Looks like this, approaches the 1. It doesn't touch the 1, it gets closer and closer to it. Let's take points on the farthest end there, then we'll come back to the middle after that. More than the 1. Let's try the 2. 1.7. Let's try the 10. 1.02. So you can see where it's approaching the 1 again. That means it's going all the way to infinity, like this in between them. If it's going up, it was coming from all the way down, decreasing. Between them, let's pick some points between the -1 and the 1. Let's start with the 0. That's a -1. Let's start with the 0.5. -1.7. So this piece, it looks like this. It's coming down. And let's try the -0.5. Is that a -1.7 too?
Yes.
That's what the graph looks like. 5, 6 points. By knowing the asymptotes, we can figure everything. And we can ask this question, what's the limit as x approaches the -1 from the left side? Positive from the right side. Approaching the 1 from the left side. From the right side. Positive. So if you graph it, you can answer all these questions. We can find the infinite limits now. And actually that was the last piece